Hello, my friends. Hey, we're continuing with conic sections, this time with parabolas. And by the end of this video, the hope is that you'll be able to recognize their form, their equation in a new way, that you understand the terms associated with parabolas when it comes to conic sections, and that you would be able to graph them in this new form that we're learning. So for a second, let's do a thought experiment. Let's pretend we have a point right here. Let's draw a point, and let's draw a line down here. All right, and the thought experiment is I want you to draw me a bunch of points that are equidistant to that line and to the point, so that they're the same distance between the line and the point. So for example, we could draw one right here, probably in the middle, right? Because it's the same distance from that point, that blue point, to both the line and that black point. All right, so what happens when we move up a little? Let's move out to here. Let's plot a point out here. And what I mean is, this line right here that we just drew is about the same distance, right, between that line and the point. Now, if we drew it right there, we could also draw it on the other side. It should hold true on this side as well. So let's make sure that's the case. So we draw our point there, and look at that. It's about the same distance between the line and the point. And let's try another one. Let's move up on the left side a little more. Let's move up to maybe here. So we're above the point. And let's do the same thing on the other side, and we'll test these points right here. Okay? Now, and these aren't perfect measurements, but if I drew those out, I would find that, oh, those are about the same right there. So that's what I mean. Now, if you drew all the points, the infinite amount of points that were in between our initial point, and I'll color it in red right now so we can see it a little clearer, and the line, what shape would we have? Well, there's no mystery to it. You see the big bold letters at the top of the screen and the name of this screencast. This is a parabola. So maybe you've never thought about a parabola in this way, but one of the interesting properties of a parabola is that all the points on a parabola that make the parabola are equidistant from a point in the middle that has a special name, and we're going to call that the focus. So this is the focus right here of the parabola. And then this line down here, they're also equidistant from that line. That line is called the directrix. Directrix. Say that 5 times fast. So that is what the parabola lies between. Now there's some other interesting properties here involving the parabola and its distances. Now, first of all, this point at the bottom, we already know what that's called. That's called the vertex. We know that from graphing previously. Now the vertex is halfway in between the focus and the directrix, and we're going to call that distance right there P. So we'll call that distance P. Now there's some interesting properties involving that distance right there. For example, the focus. It turns out that the focus, if this was on an XY plane, and I'll just draw some dots right here, the green, let's pretend that that's an XY plane that goes right through the vertex. The vertex is at the origin. Then the focus, the coordinates of the focus are 0, comma, P. Interesting. So let's take note of that. Also, the directrix, its equation, it's a line, will be y equals negative p. So the directrix is y equals negative p. It's a horizontal line. Finally, if we take the distance from the focus right in the middle, and we draw a line out to the parabola on either side, that distance right there, and let me see if I can switch colors again. I'll go yellow for this one. That distance right there is called the focal diameter. The focal diameter. And the focal diameter, it turns out, right out here, has a distance, or its max distance, if you did it as an absolute value, it would be the absolute value of 4p. So that's 4 times the distance from the vertex to the directrix would be the focal diameter. And that could help us graph it. If we knew the focal diameter, we could plot a point here, plot a point here. We would know the vertex, and we could plot our parabola. Now we're used to seeing a parabola in the equation form of y equals a times x minus h, all of that squared, plus k. And remember, with h and k, depending on those values, we can move that parabola around the graph. In this case, we're just working from the vertex. So, or at the vertex is at the origin. So we can disregard h and k for the moment, which would give us something like this: y equals a x squared. And for our purposes here with conic sections, we're going to rearrange this even further and put the x squared out front. X squared, and we're going to say that x squared equals 4p y. And that is going to be our form for conic sections until we add translations. But look at that for a second and recognize 4p is that distance, is the focal diameter that we found up there in yellow. And that p variable is that distance between the vertex and the directrix and the vertex and the focus. So some interesting things going on there. Now, the same thing holds true if we drew a horizontal parabola. So if we had a horizontal parabola that opened this way, everything is just flipped in the x and y. So as you can imagine, it would be y squared equals 4px. And we would have to move p around so that when it's the focus, the p's would switch places. But we'll get to that in a minute. But be aware that that is coming. So that leads us to a formal definition for a parabola. A parabola is the set of all points in the plane that are equidistant from a fixed point called the focus, and a fixed line called the directrix. I got my T, directrix. So there you go. There's an intro to parabolas. So follow up with the next videos for a couple of examples on how to solve them with their forms. And be sure to check out, be aware, look for parabolas in your everyday life. If you're playing Angry Birds, the shape of that path right there is a parabola. Look, a dolphin jumping, or you could draw somebody throwing a football. Ooh, follows the path of a parabola. The Golden Gate Bridge, my favorite city in the world, San Francisco. If you make it out there, you'll see it everywhere in suspension bridges. So take a look out for parabolas. They're all over the place. Conics are going to be great. This is going to be a great section. All right, check back in a minute.